Large language models are powerful, but their knowledge is frozen at the moment they finish training. Ask about something that happened last week, or about a document sitting on your own laptop, and the model simply has no idea. Retrieval Augmented Generation, or RAG, fixes exactly this. Instead of relying only on memory, it gives the model a searchable library of your own knowledge to draw from. And underneath all the variations you will ever see, every RAG system is built from the same four foundational parts: data preprocessors, embedding models, a vector database, and the language model itself. Let's meet each one. It all starts with your raw knowledge: PDFs, web pages, support tickets, spreadsheets. It's messy, it's inconsistent, and it arrives in every shape imaginable. Data preprocessors tame all of this. They clean the text, strip out the noise, and split each document into small, focused passages we call chunks. The real art is in the size. Each chunk has to be small enough for the system to handle efficiently, yet large enough to still carry a complete, self-contained idea. It's the least glamorous step in the entire pipeline, but it is quietly the most important because every single stage that follows is built directly on top of these chunks. Here's the core problem. A computer can't compare the meaning of two pieces of text the way you and I instantly can. An embedding model is what solves it. It reads each chunk and turns it into a vector, a long list of numbers that captures what the text actually means. The trick is to picture that vector as a position in space. Suddenly, meaning becomes something geometric. It becomes distance. Chunks about cats land right next to other chunks about cats. A chunk about car engines lands far away in a completely different neighborhood. Similar meaning, similar position. That one simple idea is the foundation that makes everything else in RAG possible. After embedding, you don't have a handful of vectors. You have thousands, sometimes many millions of them. A vector database is purpose-built to store all of them and, crucially, to search them by closeness in meaning, rather than by matching exact keywords. So when a user's question comes in, it gets embedded into a vector too and dropped into that very same space. The database then finds its nearest neighbors, the small handful of chunks sitting closest to the question, the ones most likely to contain the answer. And it does this in a flash, even when it's searching across millions of points. Last comes the language model, doing the thing it is best at, writing a clear, fluent, natural-sounding answer. But there's a key difference now. It no longer has to answer from memory alone. Along with the user's original question, it's handed the chunks we just retrieved, dropped straight into its context window. Now it can ground its response in those real, retrieved facts, which means far less guessing and far fewer hallucinations. It's the same model as before, but now it's reading from an open book instead of reciting from memory. So let's put it all together. Here are the four foundational parts working as a single pipeline. Preprocessors prepare the knowledge. Embeddings turn that knowledge into vectors. The vector database makes those vectors instantly searchable. And the language model turns whatever gets found into a grounded answer. Understand these four building blocks, and you understand the foundation that every RAG system, no matter how advanced it gets, is built upon. A RAG system in a single line, a language model, finally given a library it can actually search.